Okay, we're going to talk about linear functions. So we're going to start with a few terms. So we have linear equation in two variables. We've looked at linear equations. That is like y equals mx plus b. It is an equation that when you graph it, you get a line. Hence the word linear has the word line in it. So a linear equation in two variables is where you have x and y, and it's an equation that can be written in the form y equals mx plus b, where m and b are constants. And remember, constants mean it is just regular numbers, and m is slope. Next we have a linear function, and a linear function is a function whose graph is a non-vertical line. It is a straight line, and it is not vertical, meaning it is not straight up and down. Then we have a nonlinear function, which is a function whose graph is not a straight line. So it has a curve. Or you can say that its slope is not a constant, meaning its slope is not the same for the whole graph. Okay. So we are going to say, is this a linear function, and why? So I have a graph like this. So my graph here is a parabola. It's a U shape. And this is not a linear function. Not a linear function. It is not a straight line. It is curved. Then we can look at this one, and we have the line. So we're going to say yes. It is a linear function because it is a straight line. Its slope is constant. Nonlinear, not a straight line. Linear is a straight line. Okay, now if I give you a table of values, I have x and y coordinates. Is this linear or nonlinear? I can graph it, and in my graph, I'm going to have this blue line here, and we can find our slope. Our slope is rise over run, and to get from one point to the next, I go up 3 to the right 4, up 3 to the right 4, up 3 to the right 4. So we can also do that by finding the value. So we have an equation, m equals y2 minus y1 over x2 minus x1. This is the rise over the run. How much the y is changing for how much the x is changing. So to fill in this, I'm going to call this point 1 and this point 2. So I take my y from point 2, my y, and plug it in. Minus y from point 1. So I have 6 minus 3 over x from point 2 minus x from point 1. So then if I do that, I'm going to get 3 over 4. 6 minus 3 is 3. 8 minus 4 is 4. And that is my slope. That means I go up 3 to the right 4. Up 3 to the right 4. Okay, let's look at a few more examples of graphs and say if they are linear or nonlinear. If I have a graph like this, I look, is it a straight line or not a straight line? This one is not a straight line, so it is nonlinear. This one, we can see it is linear. It should be a straight line. Straight lines are linear. Next we have this one. It looks like a V. This one is not linear. It is nonlinear because it is not one straight line. It has a corner right here. Also, its slope changes. Its slope here is negative because it points down and to the right. Here, my slope is positive. It goes up and to the right. So the slope changes. It's not one straight line. It is not linear. Let's look at this one. This one is non-linear. It has a couple curves in it. It's not a straight line. The slope changes. Slope is different at this point than it is at this point. Now, what if I have a bunch of dots? This one is still not linear because it still does not have curves. Or it does have curves, its slope is not the same. And finally, if I have just a bunch of random dots, up, down, up, down, if I were to connect them, I would get not a straight line. They might individually be straight lines, but all together, it is not one straight line. So it is non-linear.